In this video, we learn how to solve one-step linear inequalities. Now, what we mean by one-step linear inequalities are any inequalities looking like x plus b less than or equal to c, or a times x greater than or equal to b, or even x over a less than b. Now, we're going to work through a few examples on these, but first of all, let's just remind ourselves of the most important rule when solving inequalities. As soon as we multiply or divide both sides of an inequality by a negative number, the inequality symbol must be reversed. Now, keeping that in mind, let's go ahead and work through some examples. As a first example, say we have to solve x plus 2 greater than or equal to 6. Well, in this case, we can see that 2 is being added to x, so to get rid of the 2, we need to subtract 2 from each side. And that would look something like this. X plus 2 minus 2 greater than or equal to 6 minus 2. And that leaves us with x greater than or equal to 4. And that's the solution, x greater than or equal to 4. And we can represent this solution on the number line. We draw a number line like so, say 0 is here, and say 4 is somewhere here. We place a dot above the 4, and x is greater than or equal to 4, so it's all the values to the right-hand side of 4. But in this case, it's greater than or equal to 4. So we fill in the dot above the 4 to indicate that 4 is also part of the solution. Let's look at another example. X minus 3 greater than 1. Well, here 3 is being subtracted from x, so to get rid of the 3, we need to add 3 to both sides. That would look like x minus 3 plus 3 greater than 1 plus 3. We're left with x greater than 4. And again, we can represent this solution on the number line. We draw a number line here, say 0 is here, and 4 is here. We place a dot above the 4, and x is greater than 4, so all the values to the right-hand side of 4. And now in this case, we leave the dot above the 4 empty, because x is greater than 4, not greater than or equal to. So x cannot equal to 4 in this case. So we leave the dot empty. 2x less than or equal to 8. Well, in this case, x is being multiplied by 2, so to get rid of that 2, we need to divide both sides by 2. That looks like 2x over 2 less than or equal to 8 over 2. Now, 2x divided by 2 leaves us with x less than or equal to 8 divided by 2, which is 4. And we represent this on the number line as follows. We draw a number line, say 0 is here, 4 is here. We place a dot above the 4, and it's all values less than or equal to 4, so it's all the values to the left-hand side of 4. And it includes 4. Remember, it's less than or equal to 4. Now, negative 3x greater than 9. Okay, well here we have x, which is being multiplied by negative 3, so we need to divide both sides by negative 3. But now careful, we're going to divide by a negative number. That means that we must reverse the inequality symbol. And that would look like follows. That would be negative 3x over negative 3. We reverse the inequality symbol, so it becomes less than 9 over negative 3. And now on the left-hand side, negative 3x divided by negative 3 leaves us with x less than 9 divided by negative 3, which is negative 3. And so once more, we represent this on the number line. Say 0 is here, negative 3 is here. We place a dot above the negative 3, and x must be less than negative 3, so it's all the values to the left-hand side of negative 3. We leave the dot above the negative 3 empty because negative 3 is not included in the solution. Let's look at two more examples. X over 5 greater than or equal to -1. Well, here we can see that x is being divided by 5, so to get rid of that 5, we must multiply both sides by 5. And that would look like follows. 5 times x over 5 greater than or equal to 5 times -1. Now on the left-hand side, these 5's cancel out, leaving us with x greater than or equal to 5 times -1, which is -5. And that's the solution. We represent it on the number line as follows. We place a 0, say, here, and -5 would be somewhere here. We place a dot above -5, and it's x greater than or equal to -5, so it's all the values to the right-hand side of -5. And -5 is included here. Remember, it's x greater than or equal to -5. And one last example, negative x over 2 less than 3. Now before we solve this, we'll point out something which is very important to keep in mind. Whether we write negative x over 2 or negative x over 2 or x over -2, these three notations are equivalent, meaning to say we can write one or the other, it doesn't matter. They'll lead to the same solution in the end. So in this case, it's convenient for us to think of this as x over -2 less than 3. So here we can see that x is being divided by -2. So to get rid of that -2, we need to multiply both sides by -2. But careful, we're multiplying by a negative number, so we'll need to reverse the inequality symbol. And that looks like follows. That's -2 times x over -2 greater than -2 times 3. On the left-hand side, the -2's cancel each other out, leaving us with x greater than -2 times 3, which is -6. And now we can draw this on the number line. We have 0, which is here, let's say, and -6 could be here, -6. We place a dot above the -6, and x must be greater than -6. So it's all the values to the right of this dot. And that dot stays empty. Indeed, it is x greater than -6, so -6 is not included in the solution. And there we go. That's how we solve one-step linear inequalities. I hope that helps.